Okay, so we're going to run the two examples that I showed in the video lecture with the plotter. So when you open your Blackboard page, under the content area, there is this rubric here, the ODE plotters. So the fact of the matter is the first one here looks nicer. By the way, there used to be a much better one, but unfortunately there are some issues with that one. It requires Java, and sometimes students have issues with installing it. So the first one actually looks nicer, I think, but the problem is that the first one doesn't show you the null lines. And so for the systems, for most of the examples you're going to run for the homework, I'd like you to use this second one that I just found. There are probably many other plotters you can find if you Google them. This one is the one I found that shows the null lines. It's not the best one, but I think it's good enough for our purposes. So just don't click on it because nothing happens on Blackboard. Just copy, select it, and open it in a new tab. So this is what you're going to see. Unfortunately, you cannot make this picture bigger, but here on the left side, you're going to introduce the differential equations, the systems of differential equations. So let's actually start with our first example. X prime equals x minus y, and y prime equals x minus y squared. Here you can choose the viewing window, which has to be symmetric. It's plus minus something, right? So let's make the range plus minus 3, because we want to be a little bit closer to the equilibrium points. Remember, the equilibrium points on this problem were 0, 0, and 1, 1. And make sure you select here draw null lines. So select this option here, and then update plot. Okay, so these are the null lines. This is the null lines for x prime, for the sign of x prime. And remember what we said before, that if you are above it, the arrows, x prime is negative. So above this line, the arrow should point to the left. So if you look carefully, look all the way over the region above this line, including the region inside the parabola. So maybe let's actually make the viewing window even smaller too, so I can see it better. So even inside the parabola, so everything above the line, the arrows will point to the left side. They maybe point upward as it happens inside the parabola. They maybe point downward as it happens outside of it. But overall, the motion is to the left because the line separates the sign of x prime. So all the arrows are shifted to the left if you're above the line. All the arrows are shifted to the right if you are below the line. Now this region here, this may look like it's almost vertical because the sign of x prime is very, the value of x prime might be very small. So positive but very tiny compared to y prime. Let's go back to the parabola. This is the null line for y prime. It separates the sign of y prime. We determined that above it, y prime is negative. Below it, inside the parabola, y prime is positive. Notice that only inside the parabola, the arrows will point upward. The only place where arrows point upward is inside the parabola, because that's the region where y prime is positive. Outside of it, all the arrows point downward. So now if you click on various points, the solution is drawn from that point. And actually this system gives you the solution in terms of x with respect to the time t. Let's make actually the time, can I control the timeline? There should be I guess not, because it converges to the, yeah, it's not the graph of x with respect to t, it's not that great. But anyway, let's actually update the plot and let's click on some solutions near the point itself. So let's look at this. When I click at solutions near the point 0, 0, the solution moves away from the point if you follow the arrows. So that means that point is unstable. The other equilibrium 1, 1 is also unstable, although in a slightly different shape. The solution approaches the point first and then moves away from it. That's what we're going to call later a saddle. So approaches a little bit the point and then moves away from it, but the overall the equilibrium point here is not stable. Let's move on to the second example, the one with the circle. So that was, what was the first equation? So on that one was 4 minus x minus y for x prime. and 16 minus x squared minus y squared for y prime. And let's make the viewing window a little bit bigger here because the radius of that circle is 4. And these are the null lines. Again, the null line for y prime separates the movement upward or downward. So notice if you, this actually, you can see it better. Inside the circle, arrows move upward because inside the circle, y prime is positive. Outside, all the arrows are downward. X prime now, look at the line. You are below the line, arrows move to the right because below the line, x prime is positive. Again, it may not be clear here because this region looks almost vertical because x prime is very tiny compared to y prime, but it's overall shifted to the right side because the sign of x prime is positive. And conversely, on above the line, y prime is, x prime is negative, so therefore the shift is to the left. These are the equilibrium points, 0, 4, 4, 0. Let's click on some solutions nearby. It's obvious that the first one, I clicked on this, 0, 4 is the stable one. And actually, you could see now the x with respect to t and y with respect to t, right? So both of them will converge to a horizontal asymptote. X converges to 0, y converges to 4. You can, they don't actually label here the vertical axis, but you get it from the picture that it's 0, 4. The other point is like a saddle, like before, right? It's unstable, although the solution for a while approaches the equilibrium point, but then moves away from it, as you can see here. I should mention here, let's actually throw in a quick extra example. You may have no equilibrium points at all. So I'll make it that that the line and the circle will not intersect. So let's say the radius of the circle is 1. When you look at the plot, the null lines never intersect. So therefore, you're not going to have any equilibrium point. So there is no point toward which the solution converges. So from the picture, if I start here, it looks like the solution goes, y goes to minus infinity, while x goes to plus infinity, because it kind of moves to the right, although in a slower fashion. But you can have no equilibrium points. And you will see actually at the end of the class, you could have even infinitely many equilibrium points. I mean, you can have infinitely many points of intersection between the null lines. So make sure you actually run these examples on your own, and many extra examples if you want to play with the plotter, just to make sure I understand the meaning of the phase plane in the case of systems of differential equations. And that's it for today.